We're in chapter 3 on ratios and proportions. The most important chapter in Math 7. We're going to start off with something super easy. It's called unit rate. A unit, say a unit, is a one, an uno. We got a few vocab words. If something is constant, it is always the same. As in, it's just a number. A number is a constant. The opposite of a constant would be a variable because it varies. It changes. Okay? And we're going to do proportional relationships, which solve lots of problems. They don't solve all of your problems, but they solve a lot of your problems. When you have a proportional relationship, you have a constant, a number, that is represents that ratio, that proportional relationship. And that number, it comes from doing a ratio of the dependent value, y, divided by the independent value, x. And it is going to be a constant, which doesn't start with the letter K. Constant starts with a C. But we're going to use the letter K to say, this is my constant. We're going to call it K. And you get it from doing y divided by x. When we go to write equations and you multiply by x on both sides, you'll get this equation. This will be more important in another lesson, which will be harder than this one. And again, remember the x is the independent. The y is the dependent, just like on a graph, x before y. And it doesn't always have to be the letter x or y. Let's say if you were doing distance is the rate times the time. The rate is a constant. If you keep a nice constant rate when you drive, you get a better gas mileage. I would graph the time, t, before I graph the distance, d. And it's kind of like doing x and y, except we're doing t and d. Okay, so let's go over some super important stuff in real life, okay? Math 7 is some major real life stuff. So this is why this chapter is so important, because if you do not know these things, you will lose money, because it's going to help you with shopping. So let's say I wanted you to buy a 20-ounce spray bottle of hairspray. I'm thinking about that because my hair is kind of all over the place right now. I want to figure out what would be a better buy. If I got 20 ounces for $5, or if I got 10 ounces for $2.60. And this happens all the time in the store. They're like, oh, look, this bottle's bigger. You don't know if it's better or not until you find the unit rate. Which, I want you to do this the next time you go to the grocery store. Look at those little stickers that are on the shelves that say the price. Underneath it in small print, it should tell you the unit rate. But that doesn't mean we can't do it ourselves. So let's figure out the unit rate in the price per ounce. Price per ounce. Now, I'm going to get a little help from my friend here. Ringalina is trying out for the cheer squad. Math cheer squad. She has a little something to say about unit rate. Unit rate, it's so great. All you do is divide. When you get one, you're all done. I got to go have some fun. Bye-bye. Thank you, thank you, thank you. Okay. Unit rate, it's so great. All you do is divide. I'm going to put my line down for division, which looks a lot like the bar in a fraction because it just looks neater that way. So we are going to do the price per, which means divide, ounce. I want the 1 ounce. Whatever it is I want the 1 for is what I divide by. Okay, I want it for 1 ounce. So what is $5 divided into 20? Put it in the calculator. What is $2.60 divided by the 10? Put it in the calculator. Over here I get 25 cents. 25 hundredths of a dollar. 25 cents per ounce. Now, I don't normally say 1, but that's what it means. It means 1. So recognize if you don't hear a number, it means 1 per ounce per 1 ounce. And over here, I'm going to pay 26 cents per ounce. Okay, in this case, buying the bigger bottle, the 20-ounce bottle, is better because it is less than 26 cents. Okay, so this is the better buy, and unit rate helped me decide that. It's only 1 penny, maybe you don't care, but after a while those pennies are going to add up. So let's do some more problems. I'm going to do 2 long problems with you, and you will do the rest on your own. Please do not turn this in without doing every problem in this packet. Okay, so we got this problem here. Wildlife conservationists are concerned that the deer population might not be constant across the national forest. The scientists found that there were 144 deer in a 16 square mile area. Sounds important. Let's highlight it. Please get in the habit of highlighting or underlining, circling, whatever you got to do to summarize and quickly simplify a word problem. In another part of the forest, conservationists counted 117 deer in a 13 square mile area. Yet a third counted 216 deer in a 24 square mile radius, I wanted to say, but it's square. It's not circular. So this was a typo, so you see I moved the numbers around. 216 deer in a 24 square mile. Do conservationists need to be worried? Well, what we were talking about in the first place. Is it constant? Is my unit rate the same? So, first of all, before we get to the numbers, question A. Why do we care? Why does it matter? Does anybody hunt? And I don't know this because I don't hunt, but is hunting season like always the same? Are the rules always the same? Can you always hunt the same amount of deer? You tell me when you see me at school. But if you farm, how do deer affect you if you farm? What do they do? What do deer do with your crops? Deer will eat your food, your crops. And there's more than one answer to this question. Could put the food chain out of balance. I know they've been talking about like reintroducing wolves into areas of central U.S. Because they are part of the food chain. They help eat other animals, and then those animals don't eat as many of the crops. So it's all cycle of life. This is very sciencey. Talk to your science teacher about it. But if there's too many deer and they're eating all your corn, you're going to have a problem with that. That's why we put up fences and things. I don't know what else you do to keep the deer away. But let's see if this is constant. Is the unit rate always the same? So you have to think, what depends on what? Do the deer depend on the square miles, or do square miles depend on deer? So the deer depend on how many deer you see will depend on how big the area is. So this is the Y, this is the X, the square miles. My deer depend on how much of an area I'm talking about. Okay? And we do the dependent divided by the independent. I want to know how many deer per, which means divide, not all the time, but most of the time, 1 square mile. I know that there are 144 deer in 16 square miles. That's what they told me. They said 117 deer in 13 square miles. They also told me 216 deer in 24 square miles. So is it constant? Is it the same number every time? You should be putting it in the calculator. Math is a participation sport. Don't just stare at me. Don't turn my sound off. Don't drown out my voice. So when you put this in the calculator, do you get the same number every time? And the answer is What's the answer? We gotta say words. Yes, it is constant. So everyone's got about the same amount of deer running around the field. The unit rate of deer per 1 square mile is 9. 9 deer for every 1 square mile. Now, is this perfectly accurate? No, it's an estimate. So you can estimate that if you're in a square mile, you probably have 9 deer. The constant of proportionality, the K value, is 9. The meaning of the constant proportionality means write the units. There's 9 deer for every 1 square mile. Now let's ask a couple questions. This is where you can use common sense, but you still got to show me work. Work meaning if you put something in the calculator, then you should be typing it on the paper. Okay? Use the unit rate of deer per square mile to determine how many deer are there for every 207 square miles. Okay, sometimes I like to use a table. Sometimes I like to use what I call the unit rate method. So I'm going to do a table right now. So I got deer in square miles. There are 9 deer for 1 square miles. I want to know what is it for 207. So I ask you, and how do I go from 1 to 9? I'm going to multiply by 9. So for my work, I'm going to put in the calculator 207 square miles and multiply it by 9, because for every 1 there's 9. For 207 there will be 1,863, write the units, deer. When you get to chemistry, you're going to end up doing it like this a lot. I label the units, and then if I don't want square miles anymore, then that's what I'm dividing by. Square miles, 1 square mile for every 9 deer. Anything divided by self is 1. And if you don't like this, that's fine. I'm going to use it a few more times until you can make a more educated decision on what you like. And then I get 1863 deer. Okay, so the unit rate, and if you just guessed multiplication, ask yourself, does that make sense? Yeah? Okay, stop. Use the unit rate to determine the number of square miles. This is a different question. I'm not looking for deer, I'm looking for square miles for 486 deer. So if this time I'm giving you the deer, then we're not going to do the same thing we did last time. Last time we did times, so this is an opposite question. It must have some opposite work. So we'll divide by 9. Does 54 square miles make sense? Okay, the deer is always bigger than the miles number. If I got a bigger miles number, then I know I did something wrong. When you do something wrong, then you do something different next time to get it right. Okay? Multiplication to get the deer, divide to get the miles. Okay, let's go to the next problem. Brandon came home from school and informed his mother he had volunteered to make cookies, aka he volunteered his mother to make cookies for his entire grade level. Let's hope it's a small school. He needed 3 cookies for each of the 96 students in 7th grade. Unfortunately, he needed the cookies for an event at school on the very next day. Mrs. Roberts would be going to Price Chopper and get him some Freihofer cookies. That's what I'd be doing. Brandon and his mother determined that they can fit 36 cookies on 2 cookie sheets. Would you have remembered to underline that 2, even though it's not in numerical form? Is the number of cookies proportional? That's a good question, and that question means, do you have a constant unit rate? Is it proportional to the number of sheets used in baking? So we're going to figure that out. Create a table that shows the data from the number of sheets needed and the total number of cookies needed. It said we needed to do number of cookies. By the way, that's not hashtag. It is the number symbol. At least it is in math class. Pound sign, number of sheets. What do we know? What do we know? What do we know? Okay. Said something about 36. 36 cookies on 2 cookie sheets. So is this going to be proportional? Are your cookie sheets pretty much always the same size? So if you had 2 more cookie sheets, how many cookies would you make? If I'm going to double this, let me do an asterisk because Mrs. Roberts is grown beyond the X. And then I'm going to double this. So this would make, I could fit 72 cookies if I had 4 sheets. I need to do cookies for everybody in the class. How many cookies do I need for the whole class? Did it tell you? It didn't. So you're going to have to take a couple more seconds of work and tell me how many cookies do we need. There's 96 students, 3 each. Each in this case is going to mean you're going to what? And you're going to get. Label this. Label, label, label. 96 students, 3 cookies each. Comes out to 288 cookies total. So that's going to go in my cookie column. Tables are a really good tool, and they're really good for organization. I want to know how many sheets is that. Well, what's the unit rate? The unit rate, when I ask you for unit rate, do I want the number of sheets, the number of pans I need for 1 cookie? Or do I want the number of cookies for 1 pan? You want the cookies per metal sheet. Per, most of the time, means divide. I can choose any of these. I'm going to do 36, the information they gave me. 36 cookies on 2 sheets means I can fit how many on 1? Unit rate, it's so great, all you do is divide. When you're done, you get 1, and we're going to have some more fun. S'more. Instead of cookies, s'mores. Anyways, 36 divided by 2 comes out to be 18 cookies per sheet. Let's write that down. 1 sheet, 18 cookies. And I do this by multiplying by 18. Going this way. We're trying to find out how many sheets, which is the opposite direction, which would be the inverse. The inverse of multiplication is division. Now notice I'm writing my work. I'm writing on the paper what it is I'm doing. I'm doing 288 divided by 18, and then I find out how many sheets I need. I need 16. One more time, what was the unit rate? How many cookies per sheet? It was 18. The constant of proportionality is 18. It was 18 cookies per sheet. Let's stick with the whole table thing because it's really great for organizing. In 2 hours, it took 2 hours to bake 8 sheets of cookies. Would have taken me 40 minutes to go pick it up at Price Chopper. Just pop those Freihofer cookies in there for like 10 seconds in the microwave. This is the best thing you're probably going to learn today. I think it was 10 seconds. 10 seconds, all it takes. It took 2 hours to bake 8 sheets of cookies. If Brandon and his mother began baking at 4 p.m., when will they finish? Okay, what are the variables? What's changing in here? I'm talking about hours. Talking about sheets of cookies. 2 hours for 8 sheets. I'll get to this time stuff later. So, how many sheets do we need? We're going to finish baking. So how many did we need? Well, that was from this previous part. Remember, A, B, it's not separate questions. They're normally related. So I need 16 sheets. So there's a couple of ways to think about it. How do you go from 2 to 8? How many sheets per hour? Sheets per hour. Sheets divided by hours gives me a unit rate of 4. 2 times 4 is 8. Isn't that great? Now we got to reverse it. It's not times. It's divide. 16 divided by 4 is 4. It's going to take 4 hours. Now, this is taking a little bit of time, but it's no big deal. It's still pretty easy. 4 hours to make it, and I'm starting at 4 p.m. 4 p.m. plus 4 hours later means we're going to stop baking at 8 p.m. That's too late for me. I am done for the day by then. So I'm just going to box this in. I made cake pops once. Oh, it took me forever. I'll never do it again, and I crossed off my bucket list. Okay, so there are other questions in this packet that you're going to do on your own. Okay, see you next time.